Puan Zaitun.
Hello, hai.
Hai.
Hai. Ni semua dah masuk ke?
Saya Hazrina. Itulah tunggu budak-budak ni masuk sekejap. Kita tunggu sampai pukul 3 lah.
Boleh, boleh, boleh. Boleh. Nanti
Boleh.
nanti puan bagi tahu dekat saya.
Ah,
Boleh, boleh. Saya tunggu. Okey, terima
okey.
kasih.
Alright.
Selamat petang, Miss Hasninda.
Hello, selamat petang.
Nama saya Saya one of the lecturer untuk yang khusus ini.
Mhm.
Nak tanya Cik Has ni
Boleh
uh,
panggil saya
se-
Mai. Ah, ah.
Mai. Okay,
Ah,
Cik
ah.
Mai selalu guna ni Teams ke?
Ya, ya. Untuk meeting saya akan selalu guna Teams.
Okay. Probably kita nak cuba-cuba tengok boleh share screen tak?
Okey, jap.
Okay.
Okay, can see my screen now?
Boleh. Very clear.
Okay,
Okay,
okay.
okay. Sebab the students are increasing now, joining us. Probably we can wait a little bit for them. Is that okay?
Boleh. So we can start now lah, right?
Tak apa. I think the screen, I mean sharing is good. Kita biar dia macam ini, okay?
Oh, okay, alright,
Nanti
fine.
maybe we try a bit like after 3 minutes. Okay, we
Boleh,
are going to
boleh.
start. Okay, ya.
Boleh?
Wait for a while.
Okay,
Thanks.
alright. Thank you.
Cik Mai, saya rasa kita boleh mulakan. Okay.
Oh, okay, boleh.
Okay. Let
Alright.
me introduce you first to our student.
Okay, can.
Okay, okay. So, good afternoon, everyone. A warm welcome to our distinguished guests, fellow colleagues, and dear final year student of this pre-stressed concrete design. So today, the industrial talk is an important platform for bridging the gap between the theories you have learned in class and the realities of professional engineering practice. As you approach graduation, exposure to real design, coordination, or site challenges is essential to prepare you and your future role as civil and structural engineers. So it is very grateful that we have our invited speakers with us today, Miss Nomai Zaitul Has Ninda binti Rusli. So Miss Mai is currently a senior design engineer with over 12 years of experience.
Yeah, correct.
Yes, okay, in civil and structural engineering, she
Mhm.
has been extensively involved in major infrastructure and building projects in Malaysia, including high-rise developments, underground structures, MRT, LRT projects, as well as precast and PVC modular construction system. This is quite interesting, huh? So
Mhm.
her professional experience covers not only structural design, but also on the precast detailing, quality control, temporary works, value engineering, and coordination between consultants, contractors, and authorities. So all which are closely related to what you have learned in the pre-stressed and precast concrete design.
Mhm.
So in addition, she is also the construction design management professional certified by DOSH, CIDB Classic CIS 7 practitioner. Am I right?
Yeah, the
So
QLASIK. Yeah.
yeah, very strong emphasis on the design safety,
Mm-mm.
constructability, and construction quality.
Yep.
So without further ado, I would like to invite Miss Mai to begin her session. Over to you, Miss.
Okay, thank you. How I
Okay.
need to call you, Miss
Oh,
Miss
oh,
O?
H.
Okay.
Yes.
Oh yeah, thank you so much for your introduction about myself. So before we start, I would like to say sorry to all of you and all the students because we should have a class this morning, right? So because I have urgent issues this morning, so I have to do in the afternoon.
It's okay, Miss Mai.
Okay. So, today class, I mean like today sharing, I would like to ask, we just nak santai-santai saja kan? Just, I mean
Yeah,
like,
santai-santai is
santai
okay.
je.
Yes, yes,
Okay.
yes.
So, before further start, I wanted to wish everyone Happy New Year, and I hope everyone have their own target for the 2026 before I mean, like we reach the end of the 2026. So this is the first start for all the students to kick off start on the 2026. So since Miss O already introduced myself just now, so I just go directly to the next slide. So this is the agenda that I will brief to all the students. So today's session will begin with about myself and my educational background. This will be followed by my career journey, including my certification journey and the major projects I have been involved in throughout my professional experience. And then next, I will share some fundamental concept of pre-stress and precast concrete, as well as PPVC system to give you a clearer understanding of their application in real engineering practice. And after that, we will move on to real project insight. During this session, I will engage with all of the students by presenting real engineering problem and testing your problem solving skill through discussion and feedback. So we just need student feedback based on the real project insight. So we will conclude the session with a Q&A session followed by closing remarks. So everyone okay? Can I get some feedback from the student as well?
I think the student is giving the response by thumb up.
Oh, I see. I see. Okay. All right. If anything, let's say the student having any question, you may raise your hand or yeah. Okay. All right. Okay, this introduction, just like what Miss O just shared to you on my career. So basically, I'm a senior design engineer with about 12 years of experience in civil and structural engineering. My background covers high-rise buildings, PPBC and precast system, underground structure, and infrastructure works. So I've been involved in both design and technical coordination, including design review, value engineering, temporary works checking, authority submission and resolving site-related design issues. So mostly, even though we are at, I'm at a HQ base, but when site having any issue, I need to go to site and resolve the issue immediately. Same goes like what I did today, which I have to settle something in the morning so that we can meet in this afternoon. So I earned the CDM professional just recently on 2025 construction design management certification. So later I will brief a bit about what is CDM, which is strengthening my capabilities in ensuring design safety, constructability, regulatory compliance in line with Malaysian DOSH requirement. So recently also I'm successful passed the CIDB QLAS 6 CI7 practitioner practical assessment demonstrating excellent in construction quality with CIDB standards. So this is myself. This is my current project that I handle right now. So basically, what you can see behind me is the car park parking, which is they're using post tension slab up to level 9. So this is the first level up to level 9. So this is the level 10, which is we call it as a facilities floor. Facilities floor is included the swimming pool and gym and whatnot. So this is the tower crane, where we mentioned about the temporary works checking that we need to be done lah. So now we go through to my education background. I began my educational journey at Sekolah Menengah Kem Trendak Melaka. Then I pursued my study in civil engineering course at Sekolah Menengah Teknik Jasa Melaka. So then after that, I continue my study at Polytechnic Kota Melaka, where I obtained in civil engineering. After I completing my diploma, I was offered opportunity to work with a subcontractor in the oil and gas industry. So meaning that after I finish my diploma, I already continue working with oil and gas company. And after that, I continue my study on a part-time basis and later obtain my bachelor's degrees in civil engineering from University Technology Malaysia. So this educational and professional foundation have shaped my technical skills, strengthened my discipline and developed my passion for engineering design. So this is my career journey that I wanted to share with all of the students, where I started in the from below timeline to the upward as shown in this slide. So my current position is at the senior engineer design CNS. So it's quite a long distance to reach at the top level. So basically, what I can say based on this slide is that the journey shows that I mean like careers growth does not happen overnight. It starts from learning the basics, being willing to work from the ground up and continuously upgrading your skills. So meaning that if you can see, uh, I started from below because after I finished my diploma, I continue work with as assistant supervisor at Nadi Padu Engineering, and at the same time I continue study. So it's quite challenging, but whatever we wanted, we have to uh, ensure we can achieve that. Okay. So next we go to certification journey. So this is the certification journey that I obtained recently, Construction Design Management Professional DOSH. CDM Professional is stand for Construction Design and Management Professional. It focuses on design safety and risk management in construction project. So the main purpose is to ensure that we comply with the safety. Second is compliance with regulation. Third, constructability. So basically, for example, I give an example in PPVC or precast project. As a CDM professional, I must ensure that module or whatever precast that we need to lifting, the design lifting point should be properly designed. And then we have to ensure the lifting weights are clearly identified and installation sequence are safe before the precast element can reach on site. So this one we have to ensure, I mean like the designer have to ensure we can reduce risks such as instability, crane overloading, and unsafe manual handling. Next is about CIDB, the recent cert that I got from the CIDB, QLAS 6 CI7 practitioner. So QLASIC is a certification under Quality Assessment System in Construction. It's developed by CIDB. It's standardized method to measure and evaluate the workmanship quality of building construction project. So the system is based on there is a spec from CIDB. We call it as a construction industry standard CI7, which is it sets benchmark for quality in architectural works, mechanical and electrical fittings, as well as external works. So, for example, in concrete structure, QLASIC assessment check item is such as surface finish, honeycombing, alignment, and dimensional accuracy. In precast or PPVC project, it's also evaluate joint quality, alignment between element of the structure, and finishing consistency. So this is very important for any engineer to ensure we give the high-end product to the owner or client. So next, this is the modular system conferences that I involved recently on November, if I'm not mistaken. The events actually highlight modular construction and industrial building system (IBS) as the future of the built environment. Normally, this will be attended by the international speakers. So if you can see, this is myself. So during the conferences, I took the opportunity to ask whatever question that related to my project, which is, for example, like alignment issues, so that I wanted to know from the speaker's point of view because they already experienced. So, yeah, during conference, we can talk to the I mean like to the speakers, whatever we don't know, we must ask so that we can gain the knowledge from the others country, how they did in their country, and we bring it to our country in Malaysia. So my involvement in the modular system conference allowed me to gain practical insight into real PPVC modular project, especially on coordination between design, factory production, and also site installation. So next is I just wanted to show to all of the student where I involved with the webinar with IEM, my internship cert from Petronas Penapisan Melaka Sdn Bhd, and IBS installer course. This is the exhibition or conferences that I involved with, which is this my represented my department for International Construction Week, and then this my SS what we call it SS Architects 2024, and then this is the Rail Technologies Expo that I involved. Okay, I wanted to emphasize to all students, if you get some conferences that need to attend, better to go, because we can get knowledge or the brochure, the catalog from there, and then we can keep for our knowledge. So this is a major project that I involved with. First is MRT Line 1, MRT Line 2, Tender Bukit Chaga Station RTS project, and then Tender Bangkok MRT Orange Line Station, Underground Tunnel LRT3 package, and number 6 is first high-rise residential building using PPBC modules to Johor Residency Kuasa Damansara. So basically, the number 6 is the current project that I involved with, where we using PPBC for the residential building. So before we move to the pre-stressed concrete basic, any one of the student have any question?
No, madam.
Okay, thank you. So I move to the, sorry, I move to the next slide. Okay, I think every one of the student know about the pre-stressed concrete basic. So it's just a theory throwback based on your study, but I will present the shop drawings sample from my project. So before we proceed, we will understand what is pre-stressed concrete, key concept of pre-stressed concrete, how it works, and benefit of pre-stressed concrete. So what is pre-stressed concrete? It's a type of reinforced concrete in which internal stresses are introduced before it's subjected to external load. This is done by tension high-strength steel tendon or cable within the concrete to counteract the tensile stresses that occur under service load. So when we move to the next slide, so basically concrete is very strong in compression but weak in tension. When a beam is bent under load, cracks usually form at the tension zone. So pre-stress is introduced to reduce or eliminate these tensile cracks. So what we did by using pre-stressed concrete, we use the tendon, high strength tendons. We apply it and we do the force to the concrete. So tendon can be high strength steel wires or strand. It's more tendon can be more stronger than a normal reinforced steel, so that when tendons are released, the compression is generated at the bottom, which tries to counterbalance the compression due to the loading at the top part of the beam. So it can relate back what happened here when we applied the load. So tendon is much stronger than the normal concrete, normal reinforcement steel. So key concept of pre-stressed concrete, as I mentioned just now, it's strong in compression but weak in tension. When we apply a compressive force to the concrete, the external load are applied, the concrete remain mostly in compression, so that when we apply the tendon just now that I show, we can reduce the crack and improve the durability. So this is pre-tensioning, and we also have post-tensioning. So what make it different is that pre-tension is normally with the tendon are tension before concrete is cast. See, we have this tendon and then we cast the concrete. So we do it before concrete is cast. But when we come to post-tension, tendon tension after concrete has hardened. For example, mostly we using post-tension on site, which is, for example, like PT slab or transfer beam. However, for the pre-tension, it normally at precast factory, where we use as a precast beam, precast slab. Normally, that is the element. So, benefit of pre-stressed concrete, normally we can use as a longer span. We can get the thinner slab or beam because we use the high strength of tendon. We can reduce cracking. We have a better durability and also cost efficiency for larger span. So I think my current project, we use the parking as a post-tension slab. So this is my current project. My current project for the parking slab. So this is the duct, and then they use the tendon inside the duct. Install the tendon inside the duct, and then after that they will cast the concrete. So this is the sample of the shop drawing for my project currently. So normally the shop drawing will be done by the professional engineer, and then they will submit the drawings to the consultant, the main consultant, to review their proposal of the post-tension slab. So normally for example, on the section, this is the slab, this is the beam. So the tendon will be like this. There is a profile and up to the end, where you can see inside this slide. They use the jacking, and then they will inject the grouting inside the duct to ensure uh, there is no concrete rust or any happen inside the reinforcement.
Miss Mai, may I know whether you have muted?
Sorry, I just now I start.
Okay,
Just now
okay. Boleh, boleh
I
teruskan. Because I
uh,
think, yeah, when you start to look into the drawing, kita boleh nampak. Tapi, but a few drawing after you say about profile pun dah tak dengar dah. Maybe you can repeat a bit.
oh, sorry. Okay, from here, just now before this slide, you can hear? I mean,
We can see the drawing, the first drawing that you say that there is a profile kan, yang lebih besar daripada this page. But after that, dah lost.
oh, after but this one you can hear. Boleh dengar lah tadi.
Ya, boleh,
Oh,
boleh.
only at the drawings lah. Okay, okay, okay. Only at the drawings. Okay, I repeat back on the drawings. Sorry. So basically, this is my current project. Yang for my car park for the level 1 up to level 9. So basically, level 1 to level 9, we use the post-tension slab. So basically, normally this drawing will submit to main consultant, this drawing is done by subcontractor, but they will hire a professional engineer to produce this drawing and then submit to the main consultant. Main consultant meaning that the main contractor's consultant. So this is the plan view. The plan view, we can see the jack and jack, and then the profile of the tendon. So when you can see the section, this is the profile of the tendon duct. So this is the one that normally a consultant will review and give approval before they can start work as per the drawings, as per the specs. As per the picture here, this is the one that they did. So before, I think that is from the pre-stressed concrete. Before I move to the precast concrete basic, is there any question from student?
No, madam.
No.
Okay, thank you. Okay, precast concrete. We will learn more about what is precast concrete, why precast concrete, type of precast element, precast concrete versus conventional system, the application, and also the challenges. So I think everyone know about the precast concrete, where we cast and we cured off-site. So meaning that normally supplier will having their own factory. When they have their own factory, they will do the element at the factory, and then they will transfer to the site. And then normally it consists of like a batching plan. They will do their own batching plan so that they can control the cement, water, cost, fine aggregate, and administer whatever they wanted as per specified design. So precast concrete manufacturing process, this is their step by step before they can transport and install to at site. So first they were forming the mold, and then they're reinforcing material. They pour the concrete, waiting for curing, and then demolding, stockyard management, and then transfer to the site. So basically, as you can see in the picture, this is the form of the mole. The mole normally they will like yeah.
Korang tak nampak the slide?
Tak nampak slide. Stop sharing. I share again. Okay, boleh nampak tak?
Okay, now okay.
Tadi okay tak?
Tadi dia tunjuk drawing only.
Allah, okay. So saya patah balik lah. Sorry. It's okay. It's my problem. Okay. So ini yang saya cakap tadi lah. What we will learn from precast concrete basics. So we have we learn more on what is precast concrete, why precast concrete, type of precast element, precast concrete versus conventional system, application and its challenges. So this one I already I mentioned just now. So what is precast concrete is more on to the cast off-site. Off-site meaning kita buat dekat factory. Kita bukan buat dekat site. So normally kita panggil mereka yang buat precast ni, kita panggil dia normally supplier. Supplier. Contohnya macam supplier API, GCAS, Speed Concrete. So this is the main competitor in Malaysia. So normally diorang akan ada batching plant sendiri dekat diorang punya own factory, so they can control their own cement, their own water, sebab water pun dia ada quality of water. Dia bukan pakai water mana-mana dia ambil daripada air hujan ke, tak boleh. So dia akan guna water yang quality water. Dia ada test untuk water tu before they can use. And then dia ada size of coarse and fine aggregates and admixture. They mix according to their specified design. Specified design ni normally supplier akan check dengan diorang punya client. Sebab every project there is a different what we call it, different specification of the design and project. So macam saya punya project sekarang ni sebab PPBC, so size, coarse and fine aggregate ni berbeza sebab kita punya design mostly use Singapore punya standard, sebab PPBC ni high apa tu orang kata high standard, so dia lain sikit. So every supplier dia kena check dengan project itu sendiri, macam mana dia nak pakai cement, water, coarse, fine aggregate punya I mean like the spec lah, dia punya cement ratio, water ratio macam tu. And then this is the process daripada forming the mold, reinforcing the material, pouring the concrete, curing, demolding, and then diorang buat stockyard management, and then transport to the site. So this is the better clear picture yang biasa supplier akan buat dekat diorang punya factory. So first is forming the mold. So normally supplier ni dia akan forming every element punya formwork. Tapi formwork mereka ni normally they using like steel mold. Steel mold sebab steel mold ni senang nak bersihkan, senang nak jaga lah, dia lebih I mean like dia lebih tahan. And then second, reinforcing material. So dia pasang rebar dekat mold yang dah tersedia. For example, this is my yang gambar number 2 ni dekat my current project, kita guna API. Masa ni kita pergi dekat API sebab saya ada buat inspection dekat kilang tersebut untuk precast air well wall. So this is the mold lah, the mold, and then diorang pasang besi. So besi-besi ni saya kena check is it according to the shop drawings, dia punya spacing betul ke tak. So semua ni kita kena inspect. I mean like the engineer or the QAQC kena inspect. And then number 3 is we pouring the concrete according to the specific design, and then we waiting for curing. Lepas dah we achieve the strength, we do the demolding, and then stockyard management. Stockyard management ni normally factory tu dia kena besar. Factory kena besar sebab dia orang akan produce the precast every day, the precast element every day. So bila dia produce precast every day, so dia perlukan area yang sangat besar untuk dia letakkan setiap elemen of the precast item yang dah siap. So that is called stockyard management. And then after that, transportation and installation. So this is the example of the precast item. Yang ni macam wall lah, wall, and then diorang install dekat site. So why precast concrete? As I mentioned, it's number 1 is quality control. So it's a better strength, durability and finish because everyone can control the quality inside the factory. So yang kedua, speed of construction sebab kita boleh control kita tak macam the weather kan. Kalau dekat site tu kita exposed to weather, but off-site kita boleh buat anytime. So every day we'll be having a casting of the precast element every day. So cost efficiency is because kita kurang gunakan labor. Macam dekat site kita banyak guna labor. Macam dekat site kita banyak guna label sebab kita nak kena pasang formwork. Formwork tu kadang-kadang kita pakai kayu kan. So nak kena buat formwork kayu tu and then nak kena pasang besi. So ramai dekat site. Tapi bila dekat factory, kita kadang-kadang gunakan mold yang dah sedia ada. Jadi repetitive works tu by the same label. So kita kurang gunakan label yang banyak dekat factory sebab tu dia more to cost efficiency lah. And then durability and strength, flexibility in design. Sebab flexibility in design ni sebab dia straightforward. Normally same size, same reinforcement, but then it depends on the situation of the project site lah. And then safety and sustainability. Okay, types of precast element is first precast slab, precast beam, column, precast wall, precast foundation, and as well as precast stairs. So precast concrete versus conventional system. So normally about the manufacturing, as I mentioned, precast concrete we produce it at the factory under control condition. But when conventional system ni dekat site, we cast it on site using the formwork. Formwork can be aluminium formwork, can be guna kayu pun ada. Tapi sekarang ni normally yang saya nampak lah dekat site banyak guna aluminium formwork. Even though aluminium formwork kita perlukan labor jugalah. And then quality control for precast high, because we can consistent in mix and curing, but in conventional it depends on site condition. It will be variable lah. Speed of construction is more faster on a precast concrete, but conventional system sometimes it's slower. It depend on site weather juga. Kalau terlampau panas pun tak okay, kalau hujan pun tak okay. Then labor requirement, less on-site labor, more on-site labor for the conventional system. Weather dependency minimal for precast concrete because it's factory production because sebab biasa factory tu dia tertutup. Conventional system about the weather is high, dia affected by rain and temperature sebab temperature ni will be effect on the quality of the concrete as well. So on the cost pula, higher initial cost but faster project completion for precast concrete. Kenapa kita cakap higher initial cost? Sebab masa awal-awal untuk kita mulakan factory tu, set up the factory, it will be challenging to the supplier yang nak buka factory tu sebab dia kena ada tanah, dia kena ada factory yang bagus, dia kena ada patching plan, dia kena ada what we call it, the ingredients of the concrete, and then the mold tu bukan satu dua, dia kena ada prepare banyak mold untuk every element of the precast system yang mereka nak jual lah, I mean to the competitor of the contractor. So that's why we call it higher initial cost but faster project completion. And then conventional system is lower material cost but longer duration because effect on the temperature as well. And also others of the item lah. Okay, this is the application of precast concrete. We use at the high-rise buildings and then commercial buildings. Infrastructure like retaining wall, drainage system, we use U-drains, box culverts. And recently my project using for the LRT3 project, they're using tunnel lining segment. Nanti kalau student ada, macam bila LRT3 dah buka, kalau you lalu dekat bawah tunnel, dekat tanah Shah Alam, kat situ diorang menggunakan tunnel lining segment. Boleh nampak lah dekat situ nanti. Boleh tengok-tengok jengah dekat luar tingkap kan. Okay. And then we use at industrial buildings and also special structure like stadium, precast seating tiers yang ini ya, precast seating tiers. So dia orang buat like a stairs tapi by precast. And then marine structures. So dia akan lain sikit daripada structure yang lain sebab dia contact with water, contact with chlorine water. And then challenges of precast concrete. First is early design freeze. Sebab kita kena ensure before we can start casting the element, kita kena freeze the design sebab when they casting, dia akan gunakan design yang sama untuk contoh kata U-drain tu untuk satu projek tu 150 numbers. So 150 numbers tu diorang akan buat satu hari dalam 7 numbers of U-drain. So early design freeze tu kita dah kena freeze dah. Dia tak boleh ada lagi isu-isu apa lain supaya kita tak kacau. I mean like for designer, engineer, kita tak kacau factory punya progress. So coordination issues, tolerance and dimensional control, transportation and handling, on-site installation challenges. On-site installation challenges ni normally kita kena ada method statement. So bila nak ada installation dekat site tu, engineer atau QQC kena ada method statement so that kita boleh kurangkan isu-isu yang akan jadi dekat site. And then connection and jointing problem, quality control, skilled workforce requirement, logistic and planning, and cost initial setup. So before I end this precast concrete slide and move to the PPVC, any of the student have any question?
No.
Okay, thank you. So we move to the PPVC basics. So PPVC basic, what we will study on what is PPVC, why is it important, key features, advantages, applications, and also challenges. So student pernah dengar tak PPVC tu apa?
Tak.
Okay, so basically PPVC stand for prefabricated pre-finished volumetric construction. So why we call it prefabricated is that we fabricate dekat factory. So pre-finish pula kita finish the product, the one that we casted the PPVC termasuk dengan M&E item dan juga architectural finishing. Volumetric ni volumetric is more onto the four walls and slab, floor slab and also ceiling slab. So that's why it called prefabricated pre-finished volumetric construction. So it's a advanced construction method where entire buildings modules like a complete apartment unit lah, and dia manufactured off-site, which is same like precast, manufactured off-site in a controlled factory environment, complete with finishes, fixtures and fittings. Okay, so these complete modules are then transported to site and stacked together using a crane like building Lego blocks. So this is the one what we call volumetric. Volumetric, this one is concrete itself, and then we lift it and put on top of the lorry before we can lift at site. So before I move further, I would like to share the Navy's work. Okay. Everyone can see the Navy's work? The
Yes.
3D. Okay. So this is the the example of my current project where from the top, we can see this is the module number 1, module number 2, module number 3, module number 4. So based on the slide just now I shown to everyone, so this is one module, we call it one module. And then if I cut the section, we can go to the inside. So what I can say, the architectural fittings and M&E fittings already inside the module. And then we leave the module to the side and install on site like this one apartment unit. So this is the most important thing that engineer need to do, because the coordination is very crucial. For CNS engineer, normally on the floor slab, floor beam, the thickness of the wall, the thickness of the ceiling, and the jointing to the other modules. So this is the Navisworks 3D view that we use for this project for coordination design in between consultant, M&E, architect, and also CNS. So why is it is important? Because of course, PPPC now mostly in Singapore they already use PPPC for the apartment building, high-rise residential buildings over 10 years already, and in Malaysia we just started to start the PPPC works. Because it's faster construction, it can speed up construction by about 40 to 50%. Higher quality, safer construction. Safer construction meaning that when we use fewer workers, it will be fewer accidents. So sometimes there is an issue on site, like at the high-rise works. So sometimes it will affect on the incidents. So it's more on safer construction, and then better coordination for BIM plus PPPC. So forces early design coordination between structural, architectural, and M&E. So key features of PPVC, we have 8, but I will share on the 5 point, which is 3D volumetric modules. Just now that I showed to a student on the Navisworks, factory finish construction, faster on-site assembly, integrated M&E coordination, improve sustainability. So this is the 5 key important for the PPVC. So first key features of PPVC is 3D volumetric modules. Each modules include wall, floor, ceiling as a single rigid unit. So when as a designer, you have to ensure you have this all element and then design accordingly based on how many levels that you design. So the key features of PPVC, 3D volumetric modules. And then factory finish construction. So it will be include structural component, architectural like tiles, paints, door, and then M&E works, whatever need to conceal inside the ceiling or inside the wall like pipe, conduits, and fittings. So basically PPVC will install everything in one, and then we transfer to site to install. And then we have a faster on-site assembly. Modules are transport and installed using crane. So the crane is the temporary works which engineer have to design as well. This is important. You have to know the weight of the module that you need to lift, and then the design of the lifting frame. the lifting point as well. So you need to know everything so that you can you can check the temporary works of the crane. Okay, so construction becomes cleaner, faster, and less labor intensive when you have checked everything in one. So next is integrated M&E coordination. So this is the M&E item inside the PPVC. Electrical, plumbing, and mechanical service are built inside the module, where we require early coordination between all disciplines, like I mentioned in early slides. So improve sustainability, meaning that we significantly reduce construction waste, and we can get the energy efficiency, lower carbon emission, and less site disturbance like noise and dust pollution, traffic congestion, because we don't have to transport so many items in one at site, fewer workers on site. So we can predict the schedule, like what time you want to send this module, So advantages of PPVC, it seem like a precast concrete. It's speed of the construction, with quality control, safety, environmental impact, labor efficiency, cost predictability, and sustainability. So normally safety is the most important thing when we do construction, because we can reduce on-site hazard. When we do the work most at the factory. So application of PPVC normally mostly will do as a residential buildings. Hotels and hospitality is one of it, but not it's quite difficult as well, because hospital might be different. Healthcare facility, educational buildings like school, like my current tender project, we will do school project, which is classroom at Johor Bahru, and also one at UPM as a hostel. So currently I'm doing the tendering for JKR project, school and university dormitories. And then commercial building, and also temporary structure like worker accommodation, the simple building. So challenges of PPPC also same like precast, where we require high initial cost. Like I mentioned, it's need to have an investment for factory setup and specialized equipment. Specialized equipment meaning that we need to have a like crane, and also we need to have a machine, hydraulic jack. How will you want to use the mold, the steel mold? So this is the high initial cost lah. So and then design limitation. Uh, as I mentioned, we have to freeze the design at early stage. We cannot change any design if we already cast the element. And then transportation issues, site constraints. Site constraint is that due to the transportation or how you want to lift the module, because module is quite big compared to precast element. Precast element can be like panel by panel, but when it comes to PPPC module, we need to tackle it because it's quite big. Sometimes it's like 30 to 40 ton for one module, and then we have to comply with the regulatory, and we need a skilled worker to operate the modules, to install the modules, to connect the modules to modules connection. So this is the some picture from the factory. So this is the element of the mold. And then this is the stockyard management. This is their demolding from the formwork, and it's transport to the lorry and transfer it to the site. Okay, before I move to the real project inside, anyone have any question or want some rest because it already 1 hour talking here? Everyone is still okay?
Yes, yes, yes.
Oh, okay, great. So now I go to real project inside um, where I'm facing the issues during the project, because sometimes bila kita masuk je project, there is no sentiasa, maksud saya macam dia sentiasa smooth saja. Sometimes there is a issue during the construction or during design stage. But this one, just wanted to share with the student. The current slide show that driveway clearance height is less than 2.4 meter. Okay. In real project, design is not only about structure strength, but also about usability. So for this project, we identified that the driveway clearance height was less than 2.4 meter, which is based on the project spec. It should be more than 2.4 for driveway and 2.1 meter for parking area. So this issue usually happen when structural beam are too deep, slab thickness is not coordinated early, or wrongly constructed by contractor. As an engineer, we must detect this early during design or coordination stage, not during construction. So, but this issue normally is because of the uh, issue, the contractor wrongly casted the levels lah. So basically the solution that may involve by optimizing the beam depth, using flat slab or PT slab, adjusting the driveway gradient. So meaning that these issues, I just wanted to share that it teaches us that engineering decision directly affect daily user, meaning that not just drawings. So the second issue is missing beam at podium car park for corridor connection. So basically this is our apartment unit. So this is the parking area. So we have to close this area, but in between we will have a corridor, and then and this one, the rebar one should be the parapet wall, and above the parapet wall should be the beam. But this is the beam that they are missing. I mean, like contractor missing. So I can say these issues occurred due to the site coordination gaps. A corridor connection was introduced at podium level, but the supporting beam was missing at site as there is no RFI. RFI meaning for request for information or coordination done on site, because in drawings there is shown the beam, meaning that the drawings, the design drawings already there for the beam, but when they can't see or they misunderstood, interpret the design drawing, this is happened because they didn't raise any request for information to the consultant. So what happened if we miss this beam? So the load path become unclear, slab may be overstressed, cracking or excessive deflection can occur. So basically this issue has been resolved by post drill to the column, because we have a column left and right, so they will do the post drill here, and then use the new starter bar for beam, and then they cast together with this parapet wall. So it's already resolved. And then we go to the third the next issues, poor concrete compaction, honeycombing or formwork leakage during casting. So we can see the rebar, the big size of rebar, because this is the column. Normally column we will use like T32, T25, the higher diameter of the steel rebar. So concrete strength is not only achieved by mixed design but also by good workmanship. Normally on site, we sometimes face honeycombing, poor compaction, leakage from work joint. So I think this usually happen due to inadequate vibration, because when you apply the formwork and then you pour the concrete, you need to have a good vibration so that the concrete grow consistently over the area. So maybe because of the congested of reinforcement and poor formwork sealing. So as an engineer, we must inspect, document and decide whether repair is acceptable or structural rectification is required. So this shows the importance of site presence, not only office design. So normally, there is a representative for this inspection. So next is wall scanning mock-up for composite wall, PPVC module. Okay, scanning is non-destructive testing method using advanced scanning equipment, where we can detect whether this equipment, advanced scanning equipment, whether we can detect the wall is fully grouted, any void or gap or honeycombing inside the wall, the uniformity of the concrete or grout. So meaning that by performing wall scanning, we can ensure the wall meet the design specification, safe, and will perform as intended over its lifespan. So this process also allow us to identify and fix any issue before they become serious problem, saving time and cost in the long run. So this is the scanning item for our PPVC module jointing. Okay, next, mock-up mock-up with Hilti coring machine for Doka self-climbing installation. So self-climbing formwork system like Doka require precise anchor and coring location. So before we full install, we carry out a mock-up using a Hilti coring machine. This one, the objectives were to verify coring accuracy, to ensure no reinforcement is cut, to confirm installation sequence. We also wanted to have this mock-up because we want to prevent like a structural damage, installation delay, safety incidents. So this also require engineers to do the method statement before we can directly do on site. So next is PPVC column load test at UiTM laboratory. So this is the column load test that we did at UiTM Shah Alam lab. So the size of the sample is 0.5 meter width by 0.2 meter thickness and 3.5 meter height. So the concrete grade is grade 40 and grade 60, because my project for high residential building, level 1 to level 10 will be using grade 60, and 11 to 28 will use the grade 40. So the lower level will be high strength of concrete and the upper level will be lesser. So design calculation alone are not always enough. So that's why we conducted a column load test at UiTM lab to validate the design assumption, confirm load capacity, observe real structural behavior. So this is where theory meets reality, and what you learn in class, you can apply and verify it here. So next is a tender briefing for road and drainage works at site office. So this is myself, where I have to brief to the subcontractor about the road and drainage design works to the contractor. Why we need to brief to the subcontractor during the tender based on our design is because we wanted them to understand the scope of works, technical requirement, construction constraint, and site condition, so that when the contractor quote their pricing for the road and drainage works, they can understand the expectation and they can give us like fair pricing and reduce dispute during construction. So basically, engineers play a key role not only for design, it include the construction, cost, and also time. So basically, these issues show that real engineering is problem solving in real time. What you learn in UITM is the foundation, but what makes you a good engineer is like by observation, responsibility, communication, and continuous learning. So I think I already finished everything. Anyone have any question?
Okay, probably we can open this Q&A session. If students, you have any question for Cik Mai? Or you can put your question in the chat box as well.
Yeah,
Okay.
even though can scan here because I already did. Later also I can reply by one. Up to the student.
So maybe before they come up with the questions, I have one question for you, Cik Mai. I have I've seen your one of your contents regarding on this modular construction. So I want to know, do you have any problem because the modules comes one by one and installed directly on site, right? So how about the connection between this module and is there any issues of that connection connecting all these modules? Is my question clear to you?
Yeah, clear. Okay, I would like to share something based on your question just now. Okay. All right, just now you said about the connection, right? So the connection between module to module will be like this. Okay, imagine this is the wall from the module number 1, and this one is the module number 2. So the connection will be using wire loop, high strength wire loop, and then we will install a double bar in between wire loop, and then we ground with high strength non-shrink ground. Normally we'll use 65 grade 65 or grade 70 for the connections. So normally what we were facing is on the alignment, because at site sometimes we can't get the good like the good gapping in between the module. However, there is a tolerance that is a design project, like consultant already stated in their specs, where we cannot install more than 5 mm. So this is the connection, and then the problem can be settled because we have a 5 mm tolerance.
Okay. Is
Mm-mm.
there any authority requirements at this moment about how to say the deviations allowed during the or manufacturing or construction? Like for
Yeah, no.
example,
Mm.
yeah. Is there
So
any
requirement from the authority.
Yes, you are right. For the contractor, to build, when they do the construction, they must keep the gap, let's say, should not be more than how much?
Yeah, normally we will follow the design project by the consultant. The authority is just approved on the product itself. For example, like us is a PPPC, right? So the authority will approve on the product, but the design will need to appeal to the authority, but then it still follow the design spec by the consultant. Mm.
Very interesting, this one.
Yeah. But normally we will
Talk
liaise
more
with
about
the
this. Uh,
CIDB for the PPVC and get their approval on the product. But overall, on the normally we will liaise with the MBSA because this project at the Kuasa Damansara. So yeah, it's okay currently because everything is by consultant.
okay. Do we receive any, question from a student?
Ada okay, kejap. I check.
There is none in the chat box at this moment. Do you want to open your mic and just ask? Take the opportunity, please. Sorry, Miss Mai, do you have any in your chat box?
I check.
QS, QQR code?
I check. I still check my chat box. Respond.
Okay, I think because we already shared the QR to the student,
Okay.
probably if they are now receiving a project from us, probably they will have some tough time to do the project. Probably they will approach you.
Yeah,
Maybe
can. Yeah,
maybe
I said
just open the QR and don't close it first, in case the student
okay.
will ask you in some times later. Okay. Is Miss Mike, is that okay that we close the session now?
Yeah, can.
Okay.
Before I end today's session, I want to leave with one important message.
Oh,
Engineering is not only about calculation, drawings, or concrete and steel. Engineering is about responsibility. I mean, like leadership and shaping the future of society. Meaning that when you design a building, every system you improve will one day by using your real people, for example, like your family, your communities, jiran ke, and future generations. So don't be afraid to start small. Don't be afraid to ask questions. And most importantly, don't stop believing that you belong in this profession. So I hope today sharing give every of the student clarity, motivation, and confidence to pursue your path in engineering. And thank you for your time, and I wish all of you success in your studies and future career. So everyone can reach me also through my contact number here and also my Gmail, and also can be friend with me in LinkedIn.
and it's very kind of you sharing this very, very good reminder to not only to
Yeah,
students, especially for us as well as lecturer.
yeah. No issue, no
Okay.
issue.
Yeah.
Everyone can contact.
Yeah.
No issue. Yeah.
So, all right. On behalf of the faculty, I would like to extend our heartiest thanks to Miss Mai for this very, very good and inspiring session. and to all the students for your participation and attention as well. Thank you. So we
Thank you so
hope to
much.
talk, has enhanced your understanding about what you have learned in our course, okay, pre-stressed concrete design, and you will be applying it soon, very soon, in this real engineering, your project and also your future career lah. Hopefully, you will remember Miss Mai reminder just now, very kind one, okay, and make sure you have professional readiness. So thank you, everyone, and have a pleasant day.
Bye.
Thanks.
Thank you. Happy New Year. Bye.
Thank you.
Thank you so much.
Thank you.
Thank
Thank you.
Happy New Year.
Thank
Happy
you,
New
Miss.
Year. Thank you.